By now, you must be great at understanding the complex numbers. But what about a complex function? Not a complex valued function, but when the e to the I to the variable. What about that one? That will be a clock. Now this is a clock, and I don't want it to shine, but what it can do is it can go around at the speed I want it to. Now the speed, that will be called the angular velocity. Radians per second, how many radians the clock hand goes around in a second. And there will be a sort of time variable, which is how much time passes, and that will give you the position of the clock. Mathematically, e to the I omega t. Omega is the angular variable that is constant for us because that's just the speed we pick. And there is the time which passes, it adds on. And as time passes, it circulates around. Basically a clock, just a mathematical description of a clock. But in maths, we don't call this a clock, we call this a phasor. Phasor because it phases. Phasing is just the motion of going around.
Phasors are basically complex numbers with variables instead of angles. The rules for addition, subtraction, multiplication, and division are going to be exactly the same because it's just exactly the same math that's being done. Instead of theta, you have omega t. That's all. And just to reiterate, omega is the angular velocity here. I don't want to spend much time on these objects now because we'll use them in other lectures when it's actually used. But here is a quick visual. The visual representation of how phasors and their waves add up. Take note that these are compatible. They are moving at the exact same angular velocity. If those were different, they would cycle at different speeds, and those would give us strange effects that I don't want to account for now. For that, you have to look at the lecture titled The Wave. Also, try adding the two waves in your head and see how it fits together. See how just literally adding those two numbers that the wave represents will result in the number that gives the third wave. I mean the amplitude of the third wave. These are the moments you realize how amazing nature really is. If you've understood the phasor, here's an evolution of the phasor. It's called the complex wave. It's a complex number propagating in time as well, and if you plot out the time direction, you'll get a helix. It's a line drawn onto the surface of a cylinder. And this changes in circles as time goes on. The projections of these are two waves completely changing. This type of mathematics is going to come very handy when we talk about electromagnetic radiation and electromagnetism in general. The phasor itself is used to describe AC alternating current. So we've got a lot of applications in this area.